Alright guys, for the final part of 11.4, we're going to now be looking at the area of a regular polygon. So just remember, regular polygon just means it's any two-dimensional shape where all of the sides and angles are equal. Alright, so that's what defines something as being regular. So whenever you see that word regular, remember that word is there to tell you that all the sides and all the angles are equal for that shape. So it could be a triangle, it could be a pentagon, it could be a square, it could be any of those two-dimensional shapes that holds with this. So let's introduce you to the final formula of the chapter, which is the area of any regular polygon is 1/2 times the apothem times the perimeter. So in the first part of this lesson, we already went through the whole process of how do you get the apothem and how do you get the perimeter, right? And so we already went through that. That was really the hard part because all you have to do now is plug it into this formula. So a quick reminder that the apothem is the segment that goes from the center of your shape to the middle of a side, right? That's the apothem. So there can be obviously some legwork going into this. We're going to go through several examples on this, so this will help. You can add this to your list of formulas for this chapter. So make sure that you do that, and then that should complete the list of formulas for chapter 11. Also wanted to just mention a couple things on the back side of this page, so stay with it all the way through because we are going to talk about something called composite figures as well. So let me start moving through this with you. Alright, so let's stick with the same format that we've been using all chapter long, which is let's start with the formula. 1/2 times the apothem times the perimeter. So there's our formula. From there we're going to find the two things that we need, which are the apothem and the perimeter. And we're going to plug them in here in line 2. So here's kind of the format that I would always encourage you guys to go through. Different ways that we can find the apothem and the perimeter. All of it really depends on what they give us to start with. And so as I look at this first shape, since they're giving us one of the side lengths, that's going to make it really easy to start by finding the perimeter. Right? So if all of my sides are 14, remember that's what that word tells me, that all the sides and angles are equal. So if all my sides are 14, I can simply do 14 times 3 to get the perimeter. So if we did 14 times 3, tells us the perimeter is 42. And so now we just have to do a little side work to figure out what that apothem is. And so here's the apothem right here. I'm just going to label it with an A, so we can kind of keep our eyes on what it is we're trying to find. So one approach, again, that we can always take for any regular polygon is to start with this angle right here, which we know as half of a central angle. So the central angle for any regular polygon is where you would do 360 divided by the number of sides. Right? That's something we talked about in part 1 of this lesson. Since we're only finding half of a central angle, all right, this only represents half of the central angle, instead of using 360, we use 180. So I'm going to do 180 divided by the number of sides in order to get that angle that I see right there. So 180 divided by 3 is 60, and so that tells me that this is a 60-degree angle. So right off the bat, I'm recognizing this is a 30, 60, 90 triangle. Squeeze that 30 in there. And so based on that, we could use either 30, 60, 90 rules to get the apothem, or we could use sine, cosine, or tangent. So it's really a matter of preference. This one does say round to the nearest tenth. And so because of that, I don't have to leave my answer as a radical. I can put it into a calculator, which means I can use sine, cosine, or tangent if I want to, but we don't need to. We know that this entire length right here is 14, which means the apothem, remember the apothem hits the middle of that side. So if this whole thing is 14, that tells me this guy is 7. And so as I look at this from a 30, 60, 90 point of view, this is the long leg. Here's my short leg. So I know in this shape, if I do 7 divided by the square root of 3, I get my apothem. I think that would be the easiest way to go. And in this case, it's actually okay to leave the radical on bottom for now because it's all going to go into my calculator anyway, because this one says round to the nearest tenth. So from here we could really just type it in. If you wanted to take a little shortcut, you could look at this and say, well, I know half of 42 is 21. So I could do 21 times this, or you could just punch it all in. It really doesn't matter. I'll just put it all in for now. So 7 over the square root of 3. Times 42. And there we go. So that would be the area of that triangle. So about, if we go to the nearest tenth, 84.9. Be careful on your rounding. And I'm not using sine, cosine, and tangent on that one because we're going to get plenty of opportunity for that on these other shapes. So whenever we see the 30, 60, 90 or 45, 45, 90, I always try to take advantage of those. Because on a lot of the other shapes, you kind of have to go with sine, cosine, or tangent rules. So there's 3 shapes that will create a 30, 60, 90 or a 45, 45, 90. And that will be the triangle, the pentagon, or sorry, not the pentagon, the hexagon, 6-sided shape. So the triangle, here we go, the hexagon, and the square. Those are the 3 shapes that will create special right triangles where you don't have to use sine, cosine, or tangent. So let's jump to the pentagon and you'll see the difference on this one. I'm going to start with the same setup here. So let's go with the formula. And let's start plugging in some numbers. We're going to find our apothem. We're going to find our perimeter. Let's just take advantage of whatever they give us to start with. Guys, when you see this right triangle, don't forget to consider all your basic right triangle processes. Like Pythagorean theorem is a good way to go. If they give you enough information, you can use Pythagorean theorem. You can use sine, cosine, and tangent, 30, 60, 90s, right? All those things are fair game, so always consider all of those. Just depends on what they give you to start with. So as I look at this one, the easiest thing to find first will be the perimeter again because they're giving us a side length. So if all of my sides are 10, I can simply do 10 times 5 to get my perimeter. The apothem, again, I want to start with this process to figure out what my half of a central angle is. So if I did 180 divided by the number of sides, it's going to give me that angle, which I think is 36, but let me just double check. There we go. So that tells me this is 36 degrees, which is not one of our special angles, so I do need to use sine, cosine, and tangent. So we're back to your SOHCAHTOA acronym. Let me just throw it in here real quick so I can refer to it for you. I'm sure you guys are all pretty comfortable with this one by now. Again, if the whole thing is 10 down here, I know that half of it would be 5. So from the angle that we know, 5 represents the opposite leg, and we are trying to find the adjacent leg. And we know that tangent is the one that does opposite over adjacent. So we're going to say the tangent of our angle is equal to opposite over adjacent. And so there's going to be our setup. Remember, when your variable is on bottom, I always want to take it and multiply it over to the other side. So I'm going to bring my a over to this side. And then before I go to my calculator, I always want to get the variable by itself. So in order to get a by itself, I'm going to need to divide this over to the right. So in the calculator, we're going to see 5 divided by tan 36. So as we type that in, make sure you're always in degrees, not radians. So 5 divided by tan 36. And we're seeing this value here. So guys, this brings me to a really important point that I want you to consider. We're rounding the nearest tenth, but not till the end of the problem, right? So I want to go a little deeper on this just for the sake of accuracy. If I round to the nearest tenth now, it might affect my overall answer. So don't do that too early in the problem. I always encourage you guys to go 3 decimal places within the middle of the problem. So I would actually write this as 6.882 for the apothem. So there's the full information. Now we can go ahead and just plug it into the calculator. And guys, to be honest, what I do is I don't round at all. I just take the answer that's already in my calculator and apply it to this. I know that half of 50 is 25. So really all we're doing is multiplying our apothem times 25. So all I'm going to do is hit times 25 so that I don't have to round this at all, and now I know for sure that this is the accurate answer. So if we round that to the nearest tenth, we're going to call it 172.0. And there we go. So guys, these are really the two main types of problems we're going to get for this whole section, right? One is where you have to deal with a special right triangle. The other is where you have to deal with SOHCAHTOA. So let's go on to another one for practice here. Let's look at the square. Now, if I really wanted the area of the square, I don't have to use 1/2 AP, right? If I know this, wouldn't the area just be 15 times 15? It would, right? So I already know the answer is 225. Okay, I already know that's the case. But here's the issue with the square. Sometimes they don't tell you this side. Sometimes they'll give you the radius, or they might give you the apothem, and then you have to work with the shape from there if we don't know all the information necessary. So obviously in a test situation, of course I would just do 15 times 15 and get my area. But I just wanted to point something out on this problem. When you get a square, if I did my half central angle, so 180 divided by the number of sides, I get 45 degrees. So hopefully that angle stands out to you. This is obviously then a 45, 45, 90 triangle. Right, and we have processes for working through that. So if the whole thing is 15, I already know that this is 7.5, and so is this, right? Because it's a 45, 45, 90 triangle. So yes, I could do 15 times 15. I could also use the formula that I have now, which is my 1/2 AP. So my apothem is 7.5. And my perimeter, if I did 4 times 15, would be 60. So you do have some options on how you want to approach this. So I already know the answer is going to be 225. But I just wanted to point out that the square does create a 45, 45, 90 triangle, and sometimes you might have to work with that. So if they were to give you, say, the radius, right? If I knew this number, I'm going to have to do a few things. I'm going to have to divide it by the square root of 2 to get this. I'll then know that this equals this, and I can kind of keep working through the square to find more information. So I want to show you, let's do 2 more. I'm going to do 4 and 6. I'm going to do 4 and 6. We can skip 5 because it's very similar to ones we've already done. So I want to show you 4 because the hexagon, the 6-sided shape, is the other shape that creates a special right triangle. If I do 180 divided by the number of sides, then I get 30 degrees. So we're seeing this as a 30, 60, 90 triangle. And so again, you really have an option. If you want to work with radicals, go for it. If you want to work with sine, cosine, and tangent, go for it. Right? You got options on this one. Now as I look at number 4, they're starting us off with something a little different. Instead of telling us a side length, they're telling us the apothem. So we already know the apothem for this one right off the bat. It's 5 radical 3. So the only thing we have to figure out is the perimeter. So let's use our 30, 60, 90 rules to find this guy right here. So we know that in a 30, 60, 90, if we go from the long leg to the short leg, the rule is to divide by the square root of 3. Well, if I take this apothem and divide it by the square root of 3, notice what they did for us. Those guys cancel. I then know this is 5. So I think that's the easiest way to go. You could have used a tangent scenario in order to figure out what this is, and you would also get 5. If half of this side is 5, well, that means the whole side would be 10. So all these sides are 10. And there's 6 of them. So if I did 10 times 6, I got my perimeter. Guys, I want to point something out on the test. You may have an option. Leave your answer in simplest radical form, or round it to the nearest tenth. So for those who don't mind working with radicals, I could easily avoid the calculator on this. I know half of 60 is 30. And if I did 30 times 5, I get 150. So at the end of it, I could write this as 150 square root 3. And that totally works. Or you could type this into a calculator and give a decimal and round it to the nearest tenth. So I'll leave that option up to you if the directions don't specify otherwise. All right, let me jump to number 6. And then I got a couple things to show you on the backside. So I wanted to do this one, even though we've already done a pentagon. I wanted to do this one because now they're starting me with an apothem instead of a side length. So just a little different. So obviously on this one I want to start with the apothem because that was already given to me. I already know it's 7.5. So the side work is going to come in finding the perimeter. So how do we do that? Again, we always go back to our half of a central angle. So as we do 180 divided by the number of sides, we're going to figure out that half central angle is 36 degrees. So we're back to our sine, cosine, and tangent on this. And typically you'll notice we often use tangent because we're dealing with the two legs of that triangle unless they give us the radius to start with, which they don't typically do, but that will happen. And so we could just use a different trig function if they gave us this instead of this. So for this one, we're going to say the tangent of our angle is equal to, I'm going to put an X right there, is equal to the opposite leg over the adjacent leg. Oops. So tangent is equal to opposite over adjacent. If I multiply that over to the left, I'm looking at 7.5 tangent 36. And again, guys, I encourage you not to round too shallow until we're done. We're not done yet. So again, I encourage you to not round at all if possible. I'm going to call that 5.449. So what I do, and this would be safe if you're ultimately rounding to the nearest tenth, but I don't even go there. I just take this, I leave it in my calculator, and I'm just going to multiply it by this. So I'm going to hit times 7.5 times 0.5, 1/2. Right, and now I know my outcome is accurate because I didn't round at all in the middle of the problem. So 20.4. Guys, of course you have to show work when doing this kind of stuff, so make sure always that gets included. But let me take you to the back side of this. And this is something that we have already seen a little of, but let me point out a couple for you. So we did some of this earlier in this chapter. What they're asking you to do on these guys is to find the area of the shaded region. Now I know this is a little unclear, but because it's a copy of a copy, but this is my shaded region right here. And the way I always encourage you guys to approach these is lay out a blueprint for yourself of what you're trying to do here. I can see that this is a rectangle overall, and I need to get rid of half of a circle so that I'm only left with the blue stuff, right? So personally, I would even write that out. I say I'm going to take a rectangle, and I'm going to subtract half of a circle. From there, I would throw in the formulas. So I'm going to take a rectangle, which is base times height, and I'm going to get rid of half of a circle, which is pi r squared. Now guys, on the test, depending on which test we're taking at the time, I will often give you this process question by question. Like the first question may ask, what's the area of the rectangle? Well, if we just did base times height, 50 times 30, so 50 times 30 would be 1,500, right? So we have the area of the rectangle. Sorry, my computer froze for a sec, so sorry if there's a little glitch in the video. So that's the area of the rectangle, and again, that might be just the first question that pops up, just to make sure that we're starting to walk through this process correctly, right? Then it might ask you, what's the area of half of a circle? And we could come up with that value. So if we did half of 225 pi, so 15 squared is 225. So the area of half of the circle is 353.4. Guys, don't forget, you can also keep this in what we call in terms of pi, which means leave pi as pi. So I could do half of 225, or I could even write it this way, in order to keep my answer more precise, right? Instead of rounding within the middle of the problem, since we're not done yet, right? And so, again, this could be a three-step problem, right? It might say, what's the area of the rectangle? What's the area of half the circle in terms of pi? And then overall, the third question would be, what's the area of the shaded part? And this is where we would subtract. So if I did my 1,500 minus 225 over 2 times pi. And now I know this outcome is accurate because I did not round in the middle of the problem. So 1146.6. All right, let's look at number 2. So again, guys, overall, let's lay out what it is we're trying to do here. The shaded part were these areas here. Sorry it didn't come out as clear as I would have liked it when it printed. But where I'm putting those dots, that's the shaded part. Essentially, it's similar to the last one where the whole thing is a rectangle. But we're going to need to get rid of 3 circles. So let's lay out that blueprint just like this, and then let's throw in the formulas. So again, we know the rectangle is base times height. We know the area of one circle is pi r squared, which we have 3 of. Oops. I can't say 3 and write 2 at the same time. All right, so here's the general blueprint of this problem. Again, on a test, it might ask you step by step, what's the area of the rectangle? What's the area of one circle in terms of pi? And then the third question could be, what's the area of the shaded part, which is where we would subtract. So let's just start with the area of the rectangle. Now, all they're giving us on this is the radius of a circle. So let's just plug that in right away. So that part's good. So how do we come up with these guys? Well, a couple things you could look at. Let's just consider the easy part first right here. Right? Remember, guys, if the radius is 5, what would the diameter be? It'd be 10, right? And you can draw those anywhere, so including from bottom to top. So if my radius from here to here is 5, that means the diameter from bottom to top would be 10. And that's what we're seeing right here, is this would be the same as the diameter of that circle. So there's one of our values. What about the distance from here to here? Well, again, look at your radius, right? We got diameters of 10. So from here to here would be 10. From here to here would be 10. And from here to here would be 10. So total, we're looking at 30. Again, guys, on the test, it might just say, the first question, what's the area of the rectangle? We can see it's 300. Second question, what's the area of one circle in terms of pi? So if I said, what's the area of one circle in terms of pi, we would look at this, and we would say it is 25 pi. So that would be the area of one circle in terms of pi. Then the third question is, okay, now let's find the shaded area, which is where you would subtract. So in the calculator, I'm just looking at 300 minus 75 pi. So 64.4 would be the total area. Guys, let me do one more. And any of these would be fine to do. The difference on these ones is now instead of subtracting, we're adding, right? So the area of each figure means the total area. So, for example, if you were going to do number 1, you would be doing the rectangle plus half of a circle. If you were going to do this one, you would be doing a triangle plus a square, right? And so you would just do those individually and add them together, right? This one would be a trapezoid plus a trapezoid. Guys, tell you what, I'm going to do one that I'm requiring you to do for your notes. But then if you want an additional example, I'll do this one as well. So if you want to end your notes after number 1, that's fine. If you want to stay with the video and do another example for practice, you're welcome to do that. So this one, we're going to see this as a rectangle plus half of a circle. All right, so I would always encourage you guys to lay that out first, put in the formulas. It's a great structured approach in getting these things right. And let's plug in the numbers. The rectangle they're giving us, 15 and 34. So the only thing we really need to figure out here is what is the radius of that semicircle that we're seeing, right? Half of a circle, semicircle. So how do we figure out the radius on that? So look at that 15 on the left. So if that guy's 15, notice that is the same thing as the diameter of this semicircle. So if the diameter is 15, the radius itself would be half of that, which looks like this. So, guys, we've done a ton of calculator work, so I don't need to do the calculator right now. If we get this far, I'd like to think you guys could easily put that into a calculator and finish it off. So make sure you got at least this. So if you want to end your notes right now, that's fine. If you want to stay with the video and watch one more example, you're welcome to stick around. I'll leave that up to you. So as I look at this one, it looks like we're looking at a triangle plus a square. Again, I would always lay that out, and you can even do it in symbols. I don't care, but give yourself some kind of an outline of what it is you're trying to do here, right? And then throw in the formulas. We know a triangle, typical triangle, we tend to use 1/2 base times height. And a square, we just use the base and the height, and we know that the base and the height are equal when it comes to a square. So let's see what they're giving us here. So let's just start with a triangle. Remember, in a triangle, your base and your height must be perpendicular to each other. So I want to recognize that that dotted line is my height because it is perpendicular to this dotted line, which would make this my base. In the square, they're telling us right here that all of your sides are 22, which would include this. Right? This would then also have to be 22. So we know that the base of that triangle is 22. How do we figure out the height? Let's look at this line down here. Guys, from here to here, the total length is 42. Based on this, we know that the distance from here to here is 22. So if this is 22, what would the remaining portion of that segment be from here to here? Well, it would have to be 20, right? So if we subtract, we can see that the remaining portion is 20. So that's going to represent the height of our triangle. base and height of the square, they gave us 22 all around. And the rest is calculator. So the rest I'll let you do on your own. But guys, what I'm really hoping that you guys see is the process of really laying out a step-by-step, clear process of what you need to come up with in order to find an answer to these type of problems. And so if you're sticking with that process and not trying to do all the things in different parts and in your head, you're going to have a lot more success with this. So that is it for 11.4.